Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss associated Legendre differential equations and polynomials. Let's begin. We know the Legendre differential equation. Legendre's differential equation is given as, that is 1 minus x square dt y dx 2 minus 2x dy by dx plus n whole into n plus 1 y is equal to 0. But we know that Pn of x is the solution of the above equation. Then we can write in place of y Pn of x, that is 1 minus x square d2 Pn of x dx2 minus 2x d Pn of x dx plus n whole into n plus 1 Pn of x is equal to 0. Equation number 2. Now we differentiate that equation m times. This type of differentiation will be done by using Leibniz's theorem. Now differentiating above equation m times with the help of Leibniz's theorem. What is that of theorem? That is, if u and v are the two functions are multiplied, then its nth order differentiation, we differentiate it n times, then what we have, that will be nc0 d nu v plus nc1 d n minus 1 u d v. That means nc1, that is n minus 1 time differentiation of that of first function, then that term 1, that is the first differentiation of that of second function. In this way the series continued. nc2, that is n minus 2th order differentiation of that of u, and the second order differentiation of that of v d2v plus dot ncr d n minus ru d rv plus dot ncn u and nth order differentiation of v. That is the Leibniz's theorem. This one is the Leibniz's theorem for that of successive differentiation. Now here we use the Leibniz's theorem, since we have to differentiate that equation m times. We differentiate this, the product of 2, that is n times. What we have, we get that equation 1 minus x square d m plus 2 Pn of x dx m plus 2. Why that is m plus 2? We differentiated m times, but the term d2 Pnx dx square, that is 2 second order differentiation. Therefore, when we proceed m times, the term will be dm plus 2 time differentiation of that of dPnx by dx. Okay, plus that is mc0. mc0 means 1, mc1 d m plus 1 Pnx by dx m plus 1 minus 2x plus mc2 d m Pnx dxm minus 2 this is the first term. Next, second term, that is minus of second term 2x d m plus 1 Pn of x dx m plus 1 plus mc1 dm Pn of x dxm 2 plus then last term, that is n whole into n plus 1 dm Pn of x dxm is equal to 0, or one minus x square d m plus 2 Pnx dx m plus 2, that is minus 2x mc1. The term will be minus 2x m factorial divided by m minus 1 factorial, that is d m plus 1 Pnx by dx m plus 1. Next term, that is mc2 minus 2, that is minus 2 m factorial divided by m minus 2 factorial into 2 factorial of dm Pnx by dxm minus 2x d m plus 1 Pn of x by dx m plus 1 minus mc1, that is 2, just we open that of bracket, that will be 2 m factorial divided by m minus 1 factorial dm Pn of x by dxm plus last term, that is plus n whole into n plus 1 dm Pn of x dxm is equal to 0. Then we simplify this factorial term. We have 1 minus x square d m plus 2 Pn of x by dx m plus 2 minus 2mx, since m factorial means m into m minus 1 factorial, m minus 1 factorial, m minus 1 factorial cancel out from that of numerator and denominator term, only exist m, that is 2mx d m plus 1 Pn of x dx m plus 1. Here m factorial means that is m into m minus 1 into m minus 2 factorial, that will be minus 2 factorial also cancel out, only have m whole into m minus 1 dm of Pnx by dxm. Okay, then that term minus 2x dm plus 1 Pnx by dxm plus 1 minus, here also m factorial means m into m minus 1 factorial, m minus 1 factorial, m minus 1 factorial cancel out, we have 2m dm Pn of x dxm plus last term n whole into n plus 1 dm Pn of x dxm is equal to 0. Next, we rearrange the terms like d m plus 1 m plus 1 and here m, the terms are rearranging now, right, or 1 minus x square d m plus 2 Pn of x dx m plus 2 minus 2mx d m plus 1 Pn of x dx m plus 1 minus 2x d m plus 1 Pn of x dx m plus 1 minus 2m dm Pn of x by dxm minus m square dm Pn of x by dxm plus m into dm Pn of x dxm plus n whole into n plus 1 dm Pnx dxm is equal to 0. Or 1 minus x square d m plus 2 Pn of x dx m plus 2 minus 2x. Here from these two terms we take common as m plus 1 d m plus 1 Pn of x by dx m plus 1 plus n whole into n plus 1 dm Pn of x by dx m minus m whole into m plus 1 again, that is dm Pn of x dxm is equal to 0. Or 1 minus x square d m plus 2 Pn of x dx m plus 2 minus 2x m plus 1 d m plus 1 Pn x dx m plus 1 plus that is n whole into n plus 1 minus m whole into m plus 1 of that of dm Pn of x dxm is equal to 0. Let I take it as equation number 3. Now let us substitute. Let us substitute u is equal to dm Pn of x dxm. Then that equation change to, then equation becomes, that equation will be 1 minus x square d square u by dx square minus 2x m plus 1 du by dx plus n square plus n minus m square minus m into u is equal to 0, which implies 1 minus x square d square u by dx square minus 2x m plus 1 du by dx. Here I separate this like n square minus m square plus n minus m. U is equal to 0, which implies 1 minus x square d square u by dx square minus 2x m plus 1 du by dx plus that is n square minus m square, that is n plus m whole into n minus m, and n minus m taking common from these two sides, we have n minus m whole into n plus m plus 1 u is equal to 0. That is equation number 5. Now if we put v of x is equal to 1 minus x square to the power m by 2 u of x, that means v of x is equal to 1 minus x square to the power m by 2 in place of u of x, that is dm pmx dxm, equation number 6. Also u of x, what u of x will be how much? Also the term u of x will be v of x 1 minus x square to the power minus m by 2, here m by 2 from that of side, that is minus m by 2. Therefore du by dx, differentiating that term, we have du by dx is equal to dv by dx 1 minus x square to the power minus m by 2 plus v minus m by 2 1 minus x square to the power minus m by 2 minus 1 minus 2x. Since it is multiplied by two terms, differentiation of first term, second term as constant, the differentiation of second term, first term treated as v as constant, is equal to dv by dx 1 minus x square to the power minus m by 2 plus mvx 1 minus x square to the power minus m by 2 1 minus x square to the power minus 1. Is equal to dv by dx 1 minus x square to the power minus m by 2 plus mvx 1 minus x square to the power minus m by 2 divided by 1 minus x square. Then taking its dv by dx plus mvx by 1 minus x square, the common term, that is 1 minus x square to the power minus m by 2, that is the value of du by dx. Taking equation number, here is the equation number 7, then it is the equation number 8. Now its second order differentiation. Now d square u by dx square, now d square u by dx square is equal to d by dx of du by dx, that means d by dx of, in place of du by dx, that is dv by dx plus mvx by 1 minus x square, that is 1 minus x square to the power minus m by 2, the value of du by dx, or d square u by dx square is equal to, that is d square v by dx square plus m d by dx of x v 1 minus x square to the power minus 1 then 1 minus x square to the power minus m by 2. This is the differentiation like this. We treat it as one term and another term, plus dv by dx plus mvx divided by 1 minus x square minus m by 2 1 minus x square minus m by 2 minus 1 minus 2x. Then or d square u by dx square is equal to 1 minus x square to the power minus m by 2, taking common from these two terms, what will we have from that of, that is d square v by dx square plus mv divided by 1 minus x square plus 2 mv x square divided by 1 minus x square whole square plus mx divided by 1 minus x square dv by dx. Again we differentiate that bracket term here, then this term plus dv by dx plus mvx divided by 1 minus x square mx divided by 1 minus x square 1 minus x square to the power minus m by 2 that term. Next, we proceed like this, simplifying one by one. What will be the next step? The next step, that is d square u by dx square, by that means d2u by dx2 is equal to 1 minus x square to the power minus m by 2 in that of bracket term. What we have, that is d2v dx2 plus mv 1 minus x square plus 2mv x square divided by 1 minus x square whole square plus mx divided by 1 minus x square dv by dx plus mx divided by 1 minus x square dv by dx plus m square bx square divided by 1 minus x square whole square. Again simplifying that term, d square u by dx square is equal to 1 minus x square to the power minus m by 2 d2v by dx2 plus 2mx 1 minus x square dv by dx plus 2mvx square divided by 1 minus x square whole square plus m square vx square divided by 1 minus x square whole square plus mv divided by 1 minus x square. Or dtu by dx2 is equal to 1 minus x square to the power minus m by 2 in that of bracket d2v dx2 plus 2mx divided by 1 minus x square dv by dx plus m whole into m plus 2 divided by 1 minus x square whole square x square v plus mv divided by 1 minus x square. That is equation number 9. Now we put the values like this 2u by dx square, du by dx and the value of u in equation number 5, d2u by dx square, du by dx and u. What happened? Now hence putting the values u du by dx and d2u dx2 in equation 5, we get, that is 1 minus x square to the power minus m by 2, that of bracket that will be d2v dx2 plus 2mx 1 minus x square dv by dx plus m whole into m plus 2 divided by 1 minus x square whole square x square v plus mv divided by 1 minus x square is equal to minus minus, here I write 2x m plus 1 dv by dx plus mvx 1 minus x square 1 minus x square to the power minus m by 2 plus n minus m n plus m plus 1 v 1 minus x square to the power minus m by 2 is equal to 0. We put up these values in equation number 5. This will be the equation. Then simplifying that one, 1 minus x square taking common from these terms, then we have d2v dx2 plus 2mx divided by 1 minus x square dv by dx plus m whole into m plus 2 divided by 1 minus x square whole square, that is x square v plus mv divided by 1 minus x square minus that of term. In all these three terms we take 1 minus x square to the power m by 3, 1 minus x square m by 3 as common, then to that of outside the value will be 0. That means these sums cancelled from all these terms. Next, in that of second term, that is minus 2x m plus 1, inside that of bracket we have dv by dx plus mvx divided by 1 minus x square plus n whole into n plus 1 minus m whole into m plus 1 v is equal to 0, which implies 1 minus x square d2v dx square plus 2mx dv by dx plus m whole into m plus 2 x square v divided by 1 minus x square plus mv minus 2x m plus 1 whole into dv by dx minus 2x m plus 1 mvx divided by 1 minus x square plus n whole into n plus 1 minus m whole into m plus 1 v is equal to 0, which implies 1 minus x square d2v dx square plus 2mx dv by dx minus 2xm dv by dx minus 2x dv by dx plus m whole into m plus 2 x square v divided by 1 minus x square minus 2 whole into m plus 1 mvx square divided by 1 minus x square plus mv plus n whole into n plus 1 minus m whole into m plus 1 v is equal to 0, which implies 1 minus x square d2v dx2 minus 2x dv by dx plus m whole into m plus 2 x square v minus 2 whole into m plus 1 mvx square divided by 1 minus x square plus mv minus m whole into m plus 1 v plus n whole into n plus 1 v is equal to 0, which implies 1 minus x square d2v dx2 minus 2x dv by dx plus m square x square v plus 2m x square v minus 2m square x square v minus 2mv x square divided by 1 minus x square plus mv minus m square v minus mv plus n whole into n plus 1 v is equal to 0. Next term 1 minus x square d2v dx2 minus 2x dv by dx minus m square x square v divided by, here the terms are cancelled, 1 minus x square to x v 1 minus x square minus m square v plus n whole into n plus 1 v is equal to 0. mb cancel out, which implies 1 minus x square d2v dx2 minus 2x dv by dx minus m square x square x square v plus m square v minus m square v x square divided by 1 minus x square plus n whole into n plus 1 b is equal to 0, which implies 1 minus x square d2v by dx2 minus 2x dv by dx minus m square v divided by 1 minus x square plus n whole into n plus 1 v is equal to 0, which implies 1 minus x square d2v dx2 minus 2x dv by dx plus n whole into n plus 1 minus m square divided by 1 minus x square whole into v is equal to 0. That is equation number 10. This equation that is 1 minus x square d2v by dx2 minus 2x dv by dx plus n whole into n plus 1 minus m square divided by 1 minus x square of v is equal to 0. This equation is known as the Associated Legendre differential equation, that is Associated Legendre differential equation. Associated Legendre differential equation. What happened here? What are the technicality in that of differential equation? Let we have to figure out. When we put here m is equal to 0, when we put m is equal to 0, then that differential equation is reduced to, that is 1 minus x square d2v dx2 minus 2x dv by dx plus n plus 1 v is equal to 0. that reduced to the Legendre differential equation. Legendre's differential equation when we put m is equal to 0, that associated Legendre differential equation changes to Legendre differential equation. Then the solution of that equation, of differential equation, associated Legendre differential equations, that is called the associated Legendre polynomial, associated Legendre polynomials of mth order, associated Legendre polynomials of mth order and nth degree, and which is denoted by, it is denoted by P n x m, that is the associated Legendre polynomial of mth order, that is mth order and nth degree, that is P n m x. Therefore, the solution is written as, is written as V is equal to P n m of x is equal to 1 minus x square to the power m by 2, that is dm p n x dxm, that is equation number 11. This is the solution of that of associated Legendre differential equation. Then the Rodriguez formula, for that of associated Legendre differential equation will be 1 minus x square to the power m by 2, that is 1 divided by 2 to the power n factorial d m plus n dx m plus n, that is x square minus 1 to the power n. This is the Rodriguez formula for that of associated Legendre differential equation, that is equation number 12. Again, the generating function, of that of associated Legendre differential equation will be summation over P r plus m of x z to the power x is equal to two m factorial 1 minus x square to the power m by 2 divided by 2 to the power m into m factorial 1 minus 2 zx plus z square to the power m plus half. This is the generating function for associated Legendre differential equations. This form is the associated Legendre differential equation. When we implement m is equal to 0, then that change to differential equation of Legendre, then its the solution is written as Pn of m x, that is mth order and nth degree, that is the representation of the solution of that of associated Legendre differential equation, and its Rodriguez formula and its generating function. Now, using that of Rodriguez formula, we can find out the associated Legendre polynomials. Then some values of associated Legendre polynomials. Associated Legendre polynomials by using that of Rodriguez formula of associated Legendre differential equation. We have what we have, that is Pnm of x is equal to 1 minus x square dm dxm of Pn of x. When we put m is equal to 0, putting m is equal to 0, we get Pn0 of x is equal to 1 minus x square to the power 0 by 2 d0 dx0 Pn of x. That means something to the power 0 is equal to 1. Therefore, Pn0x is equal to Pn of x at the zeroth order differentiation. So, P00x is equal to P0x. P0x is equal to 1. Since Pn0x is equal to Pnx, then in place of n I substitute 0. That means P00x is equal to P0x, that P0 of x is equal to 1. Therefore, P10 of x is equal to P1 of x. P1 of x value is equal to x. Then P11x will be 1 minus x square by using that of Rodriguez formula, that is x square, here x square to the power m by 2, x square to the power m by 2, 1 by x square, that is half 1 by 2, m is 1 here, d by dx P1 of x, that means 1 minus x square to the power half d by dx of P1x is equal to x, which implies P11x is equal to 1 minus x square to the power half, that is P11x. Here P00x, then P22x is equal to 1 minus x square to the power 2 by 2 d2 dx2 of P2x, that is 1 minus x square d2 dx2 of half 3x square minus 1 is equal to 1 minus x cube, that is half dy dx of 6x. That means P22 of x is equal to 3 into 1 minus x square, that is x square, 1 minus x square P22. Then P32x is equal to 1 minus x square 2 by 2 d2 dx2 P3x is equal to 1 minus x square d2 dx2 half 5x cube minus 3x, that is the value of P3x, is equal to 1 minus x square half dy dx of 15x square minus 3 is equal to 1 minus x square half, that is 30x, which implies P32 of x is equal to 15x 1 minus x square, and so on it will be continued. This is the value of another associated Legendre polynomials. These are the value of associated Legendre polynomials by using the Rodriguez formula of associated Legendre differential equation. So, with the help of this video lecture, we understand what is that of associated Legendre differential equation. We starting from that of Legendre differential equation, putting in solution and continuing by using Leibniz theorem. Just simplify it. Substituting. Finally, we have associated Legendre differential equation and some technical aspects, of that one. When m is equal to 0, that tends to Legendre differential equation. The solution of that of associated Legendre differential equation, its Rodriguez formula and its generating function, and by using its Rodriguez formula we can evaluate the values of associated Legendre polynomials. These are the associated Legendre polynomials. So, with this useful and informative notes, let me wind up this session. Thank you.